You join. No, you're in class. Okay, we are live. Let's see if anyone's going to join.
It'll take a while. I barely even, I'm here physically, but I'm not here at all.
Okay, let's see. Let's give it a minute to see if anyone rocks off class. In the meantime,
wait, I can't
is
see
Charlie
her.
Ann on the FaceTime?
No, but I can't see her. Oh, there we go.
Hello, Charlie Ann.
Hello.
How are ya?
Do I get my book out?
Yes, please. Your notebook and your textbook. Okay, we've got a couple of people here.
Really?
Charlie Ann.
Live show.
Sorry?
Oh, so you know the other person?
Oh, yeah, my actual live show, yeah.
You know the person who didn't know, like, he didn't know your boyfriend?
Charlie. Charlie Ann, why was that? Why did your boyfriend join welcome? Okay, today we're doing root matrices.
Was that square root in one or like?
No,
That's on the line.
I mean that root.
No,
that is no root like square root is R-O-O-T.
Yeah.
This is root like a pathway. Because
I just heard the word root and it was the word.
Because today we are going over the stuff that we did in that investigation a couple of weeks ago. That's what root matrices is about. Everyone remembers that investigation?
Oh, so confusing.
Yeah. And I have pathways between those towns. I have roads. Okay, let's say each one of those roads is a two-way road. You can travel along it in either way. So the way that we can turn that road map, that information. Charlie, can you see what I'm drawing on the board? Can you see it now? Let's move you. Let's move you over here, and then you'll be able to see a bit better. Try. Can you see what I'm doing on the board? Cool. All right. We can turn that into a matrix that shows the paths between the different towns. Okay, I've got 5 people on this live stream. Please comment your name if you're watching so that I can see who's with us. Okay, we can turn that into a matrix and it will look like this. Now, some key features of this matrix. Some key features of how we draw root matrices. Each row represents traveling from. That is not a real F. Each row represents traveling from that place. So, for example, we can go from town A, town B, or town C, and each column represents traveling to. So we can travel to town A, town B, or town C. Cool. Now, I'm going to add something to my diagram over on the left over there to help us with this a little bit. Let's add something here. I'm going to add second road between B and C, okay? And we're also going to add a road that travels from A around to A, like that, okay? Yeah, I guess it does. Okay, so who have we got here? We've got Jess is with us, Glenn is with us, Zori is with us. Hi, Zori. Yeah, okay. There's a few people from my year 12 class that are with us. Ying's with us as well.
Yeah, she's away.
And yeah, some of my year 12 students from last year are with us too. You guys are more than welcome to hang around and listen to my lesson on matrices. Okay, root matrices. So we're going from, we're going to. Now the numbers that fill this matrix, now tell me how many roads I have going from this place to this place. Okay, so let's start with a couple of easy ones. If I start at, let's say if I start at A, I have one road that I can take to go to B. Yes?
Yes.
So from A to B, in that spot,
Good job, sir.
thank you. In that spot, I put a number 1 because there is one road that can take me from A to B.
Yeah.
Is everyone with me?
Yes.
Cool. How many roads take me from B to B?
None.
None. 0. Exactly. And from C to C?
None.
None as well. I can't go from C to C. Okay? The fact that there are roads exiting C, that doesn't help because that road ends at B and that road ends at A. So there's nothing that can take me from C to C. So that becomes a 0 as well. There are 0 roads that do that. Everyone with me?
Yes.
Cool. Let's fill in the rest. So what about going from B to A? 1. How about going from B to C?
2.
There are 2 roads. So I put a number 2 there. Everyone happy?
Yeah.
From C to A?
1.
1. From C to B?
2.
2. From A to C?
1.
1. Now, I've left this last spot blank on purpose. What number should I be putting in there going from A to A?
1.
Or is it 0?
No, but there's one line. You can go in a circle.
But does it count as a road though?
Yeah, it's a circle. It's a
All right, I'm
roundabout.
going to put something in that spot, and I want you to explain to me why I've put that there.
Undefined.
Why do you make this so confusing?
Oh, because you can go both ways.
Good, Selena. You can go both ways. There's a number 2 there because I can take the road going that way, or I can take the road going that way.
But there's
So
no
there
arrows.
are 2
You
ways.
said you
to
see
go.
that you can go
All
both
these
ways.
roads are 2-way roads. Okay, if there's no arrows, we assume they're 2-way roads. So since I can take that road going both ways, it means that there are 2 ways for me to get from A to A. So a number 2 goes there. Okay. Does everyone understand every single element in that
Yes.
matrix? Yes?
Yes.
Awesome. Okay. So some key things that you need to be able to do are you need to, given a roadmap like that, Charlie Ann, I'm coming to you in 1 second. Thank you for raising your hand. Given a road matrix like that, you need to be able to draw a matrix. Given the roadmap like that, you need to be able to draw the corresponding matrix. A big mistake that a lot of people made last year is they got their columns and rows mixed up. They would put from at the top and 2 to the side. So please remember to set it out like this.
Does it has to be that way?
Yes.
Oh, okay.
Yes. Keep
Is
it
there
that
any
way,
particular
please.
reason why?
Convention.
Okay.
I know that's a very unsatisfying answer. Keep it like that, please. So given a roadmap like that, you need to be able to draw a matrix like that. Given a matrix like that, you should be able to draw and explain a roadmap like that. Charlie Ann, what was your question?
I'm just going to the toilet.
What did he say? What did she say?
Charlie Ann has to go to the toilet.
At least she's polite.
Yes, of course you may. You're in your own house. You can do whatever you want. And she tripped on the way.
Just don't bring the laptop.
That is so excellent. Okay. Everyone that is watching me from home, please feel free to type any questions that you might have into the live chat, and I will answer them.
Was that Mr. Schmitty? It looks like Schmitty.
Okay.
By the shirt. It looks like
Yeah, only Schmitty would do that. Sorry, if it was Mr. Schmitty.
he's one of the
Gosh,
art teachers.
Oh, okay.
And he's a sport teacher.
Yeah, I know him as an art teacher.
Okay.
He's the best.
So this is like the basic stuff that we need to be able to do. Is everyone happy with all of this?
Yes.
Cool. And I'm going to erase it.
Okay.
Everyone happy?
Yeah. Yes.
Cool.
The opinions of those.
Actually, before I erase it, I want to point out a couple of key features. Actually, we'll do a new one that we can point out a couple of key features of. So let's draw a new one.
Oh, good.
And you guys are going to help me fill in the matrix for this.
Good night.
He's recording it. You can always just like rewatch it.
A,
No,
B,
it doesn't.
C.
record.
Oh,
You have to
so do you
download.
not re-upload these like later?
Yeah, this one will stay up.
Oh, so you told me.
Yeah, so
You can
if
now
you do
just watch it
sleep,
later.
you will have to. You can watch back on it.
Okay, let's
I'll
draw
try that.
the matrix for this. Let's draw the matrix for it. So I'm gonna put my pen over each spot. You need to tell me what
Yeah.
goes there.
0.
Good. 0. Next.
1,
1. Next.
1,
1.
Excellent.
1, 0, 0,
1.
1, 0, think, 0.
0.
Good. Okay. There's a couple of key features of this matrix I want to point out, and I want you to explain to me why those features exist in this matrix.
Mhm.
The first one is, what do I have along that dotted line there?
Deleting.
First of all, Aralyn, what is the name of that dotted line that I've drawn?
Is that the I don't know.
I just said it earlier.
I don't listen.
I'm aware.
So I don't know.
Kata?
Leading diagonal.
Leading diagonal. Good. That
That's
is the
the
leading
one.
diagonal. What numbers do I have along my leading diagonal?
0.
Zeros. Why do I have zeros along my leading diagonal here?
You can't go
Because
from B to B or A to A. Yeah.
Good. You can't. There are 0 roads that go in a circle from one city to itself.
What if they have arrows on both sides?
What do you mean on both sides?
Like on both sides of the line.
It's a
So like
two-way road.
it'll be two-way.
Like that? Yeah,
Yeah,
that just
then-
means it's a two-way road. But I still can't go from A to
Oh
A.
yeah,
because
yeah.
I can only go from A to A by going to B first or to C first, which means there are no roads that go directly from A to A or from B to B or from C to C. So the fact that I can't travel in a circle from one town to itself is why I have zeros along my leading
What
diagonal.
if it's a two-step one? You can-
Okay, 2 steps we're going to get to in a second. 2 steps we'll get to.
We just did that in the
We
thing.
did it in the
I don't know if
investigation,
it
yes.
counted
We'll
or
get there
not.
in
I
a second.
forgot.
Okay, there is something else. You know what? I'm going to leave that dotted line there.
This is the reason.
There is something else that you might notice when I draw that dotted line. Another feature of this matrix.
It's an equal number of ones and zeros on either side.
Good. What's a more succinct way of saying that? What do you notice about that matrix?
Is it pattern?
That dotted line that I've just drawn down the middle of it is a line of symmetry.
Oh,
My matrix is symmetrical. I've got 0, 1, 1, and then the zeros along the leading diagonal there. It's a symmetrical matrix along that leading diagonal. Why is my matrix symmetrical?
Because there's no two circle ones.
Okay, there's nothing that goes. So the fact that there's no circles that go from a town to itself, that explains why there are zeros along my leading diagonal, but it doesn't explain why my matrix is symmetrical. Why is my matrix symmetrical?
why not?
Is it like
Why not? What would there be? What
Is it
would there be in my roadmap that would make my matrix non-symmetrical?
because
It's
it's a
Asymmetrical.
line
across the
B to
BC,
C?
because triangle.
Okay, well let's see if we add that from C to B, then all that's going to change is that C to B is going to be a 1, and B to C is going to be a 1. That's still symmetrical.
Yeah.
So
Is it
why is it
because they're all like two-way? So it makes
exactly, Kata? Excellent. Keep going. Keep going. Elaborate on that.
like well done. It's all excellent. Try to explain. They're all two-way, so it would have to be like equal regardless. Whereas if it's like you have one way, it would like make the. Oh my goodness.
Okay, I can tell that you understand. You're struggling to put it into
It's
words.
yeah.
We're going to use some of the terminology that we developed over the last couple of weeks. The fact that all of my roads are two-way means that if I can go, for example, from A to B, then I can also go from B to A. Okay, so going from A to B, what would I call that element there? Going from A to B.
Oh my god.
From A to B. Whoops. From A to B. What's the name of that element?
Would it be like two, like, yeah, like 1, 2.
1, 2, exactly. So it's going to be A1, 2. First row, second column. Yeah? Charlie Ann, sorry. I think I've... There you go. Hopefully you can see what I'm doing now. From A to B, I would call that A1, 2. First row, second column. What about going from B to A? What would that element be called?
A2, 1.
A2, 1. What do you notice?
You just put the numbers.
Right, exactly. So if I have an element in row M and column N, yeah, so row 1, for example, column 2, then going back the other way along that exact same road is the element from row 2, column 1. These two are in symmetrical positions, this one and that one, which means if I can go from A to B and it's a two-way road, then I can also go from B to A, which means I'll have exactly the same number in both of those spots. Clear?
Yes.
Excellent. Charlie Ann, you happy?
Kinda, yeah.
Kinda, yeah. Perfect. Okay, I'll take that. I'll take that. Okay, moving on. So that's the basic stuff. That's the basic stuff.
Thank you.
Moving a little bit more complicated now. You'll remember this from the investigation. We can also make a matrix that is the number of two-way steps to get from one place to the next. So let's draw my counts again. I should probably just not erase things. I should probably just keep them
Well, start getting more than like 2. It's not going to be like
A, B, C. Let's say that is, and then let's say that I've got a one-way path. It's just a one-way path going from C to B. Okay, so first let's draw my base matrix for this. I'm going to get a 3x3 matrix. What's going to go here?
A.
Inside my matrix.
It would be 0.
What's that number going to represent? Good.
Which will be A to A.
From A to A, so that's a 0.
0.
0 and
0.
0. Good. Now, here,
1.
1. From A to B is 1. Here,
Wait, 1.
It's really distracting with the
1
letters
as well. Good.
1.
What does this one represent?
A to B.
No.
No,
B to
B
A.
to A.
From
B
B to A. So what goes there?
1.
A 1. What does this represent?
1.
What does it represent?
B
From
to C.
B to C. So what is it?
1. It'll be 0.
0. Because that's a one-way road. So I can't go from B to C. What does this represent?
From C to A.
So what is it?
1.
A 1. And this represents?
C to B.
C to B. So what number goes there? A 1.
I don't like it without the letters.
Yeah, same.
I know, that was to try and test you. So that's an A, B, C, A, B, C. That's from, and that's to. Okay, I think we've lost Charlie Ann.
Oh, bugger.
All right. Now,
Oh,
is everyone happy with this? Notice, before I move on, that we have lost our symmetry. If that's my line across the leading diagonal, these two numbers are not the same. They're not symmetrical. Why is that?
Because
one is one way.
Because it's a one-way road. Good. Now what we're going to do is we're going to take this matrix and we're going to square it. So if I call that, let's say I call that matrix R for root matrix. Okay. Let's see if we can calculate R squared. So that's going to equal 0, 1, 1, 1, 0, 0, 1, 1, 0.
Charlie's on the live stream.
Multiplied by, okay, perfect, thank you. Multiplied by 0, 1, 1, 1, 0, 0, 1, 1, 0. I'm squaring it. I square it the same way as I square any number. I multiply it by itself. Let's do this matrix multiplication altogether, because we love matrix multiplication now. What are the dimensions of my new matrix going to be? It's going to be a 3 by 3. Good. Arlen, wake up. You're helping me with this.
It's going to be the same.
Yeah, Jess, sorry, are you struggling to see the board? What if I move it closer like that? Is that better? Can you see that, Jess?
I hate this technology stuff.
Okay. Kata, first step.
Grab the first row with the first column.
Good. So what do I get?
You get 0, 0, 1, 1, 1, 1, 2, 2.
2. Good.
Yeah.
Next, Selena.
First row, second column.
Yep.
0, 1, 0 is like, yeah. No,
It's 1.
It's 1.
It's a 1. Good. Next, first row, third column. I'm going to get 0, 0, 0. Good. Next, I'm going to do my second row first column. So I get 0, 0, 0. Then I'm going to do my second row second column. So I get 1, 0, 0, which is 1. Then I do my second row third column, 1, 0, 0. Now I'm going to do my third row first column. I'm going to get 0, 1, 0, 1, 0, 0, 1, 0, 0, 1. That was fun, wasn't it, guys? All right. Okay. People at home, tell me if now that I've moved it closer, you can see it better. I know it's a bit faint. I apologize for that. If you can see it a bit better now, let me know. Okay, that is now R squared. What does that matrix now represent? It now represents the number of two-step roots from each place to each place. Okay? Aaron, you won't be confused for long. Watch this. Let's now get rid of this working, and let's just draw my matrix. So if that equals R, then 2, 1, 0, 0, 1, 1, 1, 1, 1.
Like, I got how you did it.
That equals R squared. Yeah?
But why are we squaring it?
Okay, that's what I'm about to show you. This matrix is the number. It shows the number of two-step roots. So if I'm going from A, B, C to A, B, C, that's 2. Aaron, watch this. If I'm going from A and I want to get back to A in 2 steps,
So
how many ways can I do that?
What, 2?
I can go from B back to A, that's 1 way.
Yeah.
Or I can go to C back to A, that's 2 ways.
Yeah.
There are 2 ways that I can get from A to A in 2 steps. So from A to A is a 2. How many ways can I get from A to B in 2 steps?
You can go from A to B.
I can't go from A to B because that's not 2 steps. That's only 1 step.
Well,
I can go from A
to
C to B.
B.
That's the only way I can get there in 2 steps.
Oh, yeah.
So from A to B is a 1.
So when you square it, it just means like I can get there in 2 steps.
Exactly.
Oh.
From A to C, I can't get there in 2 steps at all because that's a 1-way road, right? So I can only get there in 1 step. I can't get there in 2 steps. So that's why from A to C, this matrix is now a 0. And you can follow through the rest on your own and make sure that that keeps up. Okay, so that gives us a general rule.
Do you need water?
I think I inhaled fluff.
You think you inhaled fluff?
I like my jumper.
Okay.
I'm like,
Sure
I'm
thing.
just quietly diving.
All right, this gives us a general rule. If I have a root matrix R, let's write out this rule. Given a root matrix R,
You sound like you're dying.
I just stood up.
That's okay.
I'm going to write it like this. R to the power of n, R to the power of n shows the possible number of n step roots. So we just did R squared, and that showed me the possible number of 2-step roots. If I did R to the power of 3, that would show me the possible number of 3-step roots. R to the power of 4, R to the power of 5, etc. Now, just because so many people ask me this, during the investigation we did on this. How do you raise something to the power of on your fancy calculator? Everyone at home, look at this.
Oh, I figured
I figured it out as well.
This button here, everyone. The one that is that little arrow symbol. That means to the power of. Okay? Don't muck around with the keyboard on your screen. That button right there means to the power of. Please use that. Okay. Charlie Ann, I'm assuming that username is you. You're confused what the R represents. R represents the root matrix. So this is my base root matrix, showing me the number of possible ways to get from each place to each place.
Damn it, Charlie, we trusted you. I don't know what her username is. I know.
It's all right. We're not going to say it out loud. Even though we already have. Okay. Charlie Ann says, yes, sadly, that is me. Right. I bet you didn't expect that you'd be typing on our classroom live chat with that username when you made it, Charlie Ann. Okay, is everyone happy with this?
Yes.
Any questions?
No.
Cool.
Don't raise
Pretty straightforward.
Don't erase the writing.
That writing?
Yeah.
Okay, I won't.
I already wrote it down.
But I'm going to erase everything at the top.
Okay.
And I'll give everyone a minute to write that down, and I'll give everyone at home just a minute to ask me any questions if you have it.
Right,
So it's like, is the test for this still a go ahead or like no?
Excellent
No.
question.
I need to make sure if I need to cop batteries or not.
I mean,
Cop batteries or not.
batteries regardless.
you need batteries regardless.
But what's the plan about the
Yeah, great question. That's going to be like a wider discussion than just this class, I think, because all the classes will be in the same boat with assessments and things. My ideal situation is not going to happen, so I'm not even going to say. But no, what I think I might have to end up doing is like we might not end up actually doing an assessment on this. But if that's the case, then I'll still give everyone a test. I'll put one up on Connect and with the answers and whatever, and I'll get you to do it for yourselves because I'm assuming that we're still going to be going ahead with exams. So even if this particular assessment gets cut out of the program or whatever, you still need the practice of doing the tests and stuff.
Mm-hmm.
So even if we don't do an assessment for this topic, I'll put the test up on Connect. Anyone that's in school, I'll give you the test. I'll put one up on Connect, and I'll ask everyone to do it in test conditions with a time limit, etc. And then I'll just give you the answers for your mark yourself.
Do you expect us to anyone to follow that? Because I feel like someone's going to cheat.
No, but it's not going. If that's what I do, then it will be because the marks are not going towards your grade anyway. So it's more for you to practice.
Why don't we
do
the what is it called, the X thing that we did in human bio? None of us are human
We're not in
bio.
class.
Oh yeah, you're not in my class.
What did you do in human bio?
You know
Why don't we just do a Kahoot?
do Kahoot.
Just stream a Kahoot.
No, yuck, I hate Kahoot.
That sounds like a
You know
Can't really do Kahoot for these topics, but yeah.
you know what's it called?
Make your own Kahoot. So that's our test.
You know when we do everyone shut up and let me talk, yeah? You know the thing when when you know the thing,
You know,
Okay, think of your question, write it down, and I'll come back to you. We're gonna move on.
No, wait, it's like the FaceTime with the whole class.
That's not gonna work.
Yeah, like Zoom or WebEx.
Yeah.
Yeah.
Why don't we just do a test and then you
A
can
test on
supervise
WebEx
us.
and supervise you.
Yeah.
It's
You know the one
potential,
with my phone
but probably
texting
not.
like a week.
Okay,
Yeah.
we're going to move on. I'm going to erase this and we're going to move on. In the meantime, just update for everyone that is in the room with me. Charlie Ann has spilt ramen on her notes. I'm loving this live stream thing.
I have
It's so
ramen
great.
too, Charlie.
Okay, let's move on. The last thing we're going to do in this topic of root matrices is we're going to use this same idea of root matrices, but use it as a social interaction, not a social distancing matrix, a social interaction matrix.
So that's a sensitive thing in these times.
I know. Now that you mention that, actually, social interaction matrices are the kind of things that would probably become more important in these times because let's say, for example, I don't know when this might happen, but let's say, for example, you wanted to track who had interacted with other people so that you could follow the way that something gets passed on from one person to the next, for example. So you might want to represent that as a social interaction matrix. Okay. Social interaction matrices work exactly the same way as root matrices, except instead of showing the number of roots that go from place A to place B, we're now showing whether or not person A has interacted with person B. Okay, so for example, you can do this with any sort of examples. Example I'm going to put up is, let's say, house visits. I want to know who in the class has visited each other's houses. Okay, so let's do a house visits matrix. And it's look like this. Let's say we have 4 people in this classroom.
There technically is.
Yeah. There are 4 people in this classroom. I count as a person, Marilyn. So we're gonna do A for Marilyn. We'll do we have the same letter, so I'll use my first name. We'll use Kata and Selena. Okay, so let's say that these are the 4 people in the classroom, and we'll do those across the top as well. Notice, by the way, I've done it in alphabetical order. It doesn't have to be in alphabetical order. You won't lose marks if you don't do it in alphabetical order, but it's nice when you do. It's better, and it makes it a lot easier for me to mark. There's nothing. The thing I hated the most about this topic was last year was when in a test people would all give their answers with these letters in like different orders, so I would have to go through and try follow. And anyway, just do it in alphabetical order if you can. Okay. Now it follows the same convention that this is kind of like from, and this is kind of like to. But what this is showing now is house visits. So if I put a number 1 over here. No, let's not put a number 1 over there. Let's make this more realistic. Let's say that there's a number 1 over here. That means that Selena has visited Kata's house.
Kata's grandparents don't like people overload.
Okay, so this is a hypothetical situation. This is showing that Selena has visited Kata's house. Okay. And we could fill in the rest of the matrix like that as well. So we could say maybe Kata has also visited Selena's house.
Let's go.
Let's get it, boys.
Okay, so that would be a 1. That would also be a 1. Okay, we could fill in the rest.
Can you visit your own house?
Aha! Excellent question. Can you visit your own house? No. So do you think that across this leading diagonal, I should put 1s or 0s?
1s, because you technically go into your own house.
Okay, your own house is totally meaningless. Like, that doesn't give us any useful. So we put 0s along the leading diagonal.
Okay.
Not because you haven't visited your own house, but because saying that you have would be totally useless. We would say that maybe I haven't visited anyone's house and you haven't visited mine. Sorry. Yeah, exactly. That's why I'm going to put 0s across my row and column. 0 there, 1 there. Okay.
People.
So this is a hypothetical. So if we follow this through, then no one has visited their own house. We could say that Kata has visited Aaron's, Selena has also visited Aaron's, Aaron has visited Selena's, Kata has visited Selena's, Aaron has visited Selena's, Kata has visited Selena's, and Selena has visited Kata's. Okay? So and Selena has visited Kata's. Okay? So I just want to show that you visited Selena's house. You visited Selena's house. Okay, so I just wanted to show that as an example. We have a question from Jess, which is, what questions are we doing in the book? You're doing B. I'll write that up in a second. And we have a question from Charlie Ann. If you wanted to go to your own house, could there be endless ways? I guess if you're thinking like broader more like generally, if we're getting, then yes. But the way that we draw the matrix is we put zeros across that leading diagonal because it doesn't give us any useful information to show that you've gone to your own house.
What if it's like, what if there's a circle one? Just like, what
It's
if
still going your own house? Your own house.
No, what if it's just like not your house? What if it's like, I don't know, freaking shop to your house? Or like, I don't know, like what if like
that's just not what this is showing. That's just not what this is showing.
Can you square root if you're going to like I don't know, for example, I go to like Selena's house and I go to Arlen's and stuff as well.
Okay, good. So I guess you could theoretically square this matrix, but you have to think, is it going to give you any useful information?
No.
In this case, squaring this matrix is not really going to give you anything useful, because to say that you, like, if you've gone to Selena's house and Selena's gone to Arlen's house, then it means that in the U to Arlen block, there would be a number 2 there, right, when you square this. But that doesn't actually give you any useful information, because say that, but in some social interaction matrices, it can. For example, if I want to know who knows each other in a group, let's say I'm having a bunch of people over to my house for a party, and I want to make sure that everyone knows at least someone else. Okay, so I want to put that into a matrix. Okay, so I want to put that into a matrix. I want to put that into a matrix. Now, if I square that matrix, then that does actually give me useful information, because if there's a 1 in the squared matrix, then if we go back to your example, let's say you know Selena and Selena knows Arlen, but you don't know Arlen. But if I square the matrix, then a number 1 in the U to Arlen spot is actually meaningful, because it means that you know someone who knows Arlen, which actually gives me useful information, right? So I hope that didn't confuse you and made things clear and helpful. Just quickly before I get to your question, other things we could use social interaction matrices for, not necessarily house visits, things like what I just said, who knows each other, right? Like who has had physical contact with each other if I wanted to track the course of a virus in a hypothetical example. Things like who, like we all get together for a barbecue and I want to know like who brought presents for each other for this party that we're having, or something like that, right?
One M&M.
So for any of those, I could do the exact same thing, make a social interaction matrix. It would be as if like the from up down the side there. I could do the exact same thing, make a social interaction matrix. It would be as if like the from up down the side there and the 2 across the top there. Okay, that's everything that I needed to cover. Any final questions? Alan, you had your hand up across the top there. Okay. That's everything that I needed to cover. Any final questions? Alan, you had your hand up before?
Yeah, just saying, sir. I don't think when people host parties, they will draw a matrix.
Not unless you're a matrix.
True. I cannot say I've ever actually made a matrix when hosting a party, but do you guys know Eddie Wu? Okay, if you don't know Eddie Wu, first of all, you need to know Eddie Wu because he's the best maths teacher in the world.
That is debatable. I say Mr. Nourishin is the best.
That's very flattering to Mr. Nourishin. But no, he's a teacher. He's a high school maths teacher in Sydney with a YouTube channel that he's unbelievable. The way he explains things is just really clear. And he recently released a book where he goes through a bunch of just like cool maths things that are like to get people interested in maths or whatever. And one of them is he uses, it's not exactly like this, but he uses maths to be like, what's the largest party I can have where I still am sure that like everyone will know someone else, something like that.
That's
anyway.
so weird.
Anyway,
I mean,
any last questions?
Be anywhere with no one you know is like the worst.
Okay, we're gonna do questions in the book.
But then
We're gonna do book questions. So we're doing
it.
exercise 6C, questions 4 to 12.
Not unless you like just go
Like just like
sure
crash it.
rock up.
That's just like that. You guys have really bad ideas.
Exercise 6C, questions 4 to 12. Everyone.
I want to have a party.
I will not go.
I'm not going either.
Someone just commented, "Sorry, I have woken up late." I don't know who that
Who's
is
that?
because their username doesn't really tell me who they are.
What's the username?
Their username is Solomon Fan Club. best physics teacher, except that they've spelt my name wrong. So they're clearly not such a fan.
Maybe it's a different Solomon.
Okay, I'm going to finish this. I'm going to end this stream. The great thing about it is that it's now there on the internet, so you can go back and watch it from the beginning if you need to. See you later.
That YouTube channel.
What have you heard, Aaron?